right now, everyone is experiencing some form of radiation. Since we have windows in this room, we get radiation from the sun. There's radioactive metals inside the earth that we are getting from underneath. And so throughout our lives, we get a certain amount of radiation throughout our lives, but it's not enough to become like extremely damaging unless like with skin diseases or like if you don't protect yourself from the sun, it's usually okay to get a certain amount of radiation. But in space, it's a different story because we don't have the protection of the Earth's atmosphere and magnetic fields to prevent astronauts from getting dangerous amounts of radiation. And as a biotech major, I am interested in how radiation can affect the body and how it limits space travel currently. So I'm going to be talking about the types of radiation, the effects of radiation biologically, and how we plan on protecting astronauts from radiation in the future and currently. So the first topic is types of radiation. So according to the Space Radiation eBook from NASA, NASA's Human Research Program in 2017, there are three main types of radiation: non-ionizing radiation, ionizing radiation, and GCR, or galactic cosmic radiation. And so non-ionizing radiation is a type of radiation we get almost all day. It's from phones, it's infrared, radio waves, microwaves, ultraviolet light, visible light. That's the kind of, it's called non-ionizing radiation, and it's very low energy. And it doesn't affect you as much, it's not as damaging. But ionizing radiation includes alpha, beta, and gamma radiation. And alpha radiation, although it's damaging, it can be blocked by like a sheet of paper, so it's easy to prevent. But gamma rays are on the higher energy scale and can be difficult to block. And it usually takes about this much cement to block gamma ray, so it can be difficult in space since we don't have that like material to bring up there. But although gamma rays, well, a certain type of gamma ray is the galactic cosmic radiation, and it's caused from supernovas, or the death of stars. And so when these stars die, they release these nuclei at extremely fast rates, and they're traveling at light speed, and they have the ability to like rip through, like it just goes straight through your body, straight through like almost every material we have, and straight through the human body. And so it's extremely difficult to protect astronauts from in space. And a lot of people think you can just block it with lead, like we use lead vests at the dentist, but that's not really the case for galactic cosmic radiation, because when it hits the heavier materials, it actually causes it to break apart and releases these particles called secondaries, and it actually makes the radiation even worse. So what we use currently is polyethylene. It's the material in plastic bags, and it's super hydrogen rich, which it can't shield you completely from the galactic cosmic radiation, but it does help it helps it not cause those secondaries. And then radiation can affect DNA. It affects you biologically because it causes breaks in DNA, and when your DNA is broken, or if it can't repair itself, if the cell can't repair itself, it causes either apoptosis, or like cell suicide, or it causes proteins to be malformed. And when proteins are malformed, they obviously can't function as they should, and it can cause health risks. And according to the Journal of Radiological Protection in 2019, research showed that radiation can cause heart disease, especially 40 years from your exposure. You're at extremely high risk of cardiovascular diseases. And then it can also affect your central nervous system. And radiation hinders neurogenesis, which is the regeneration of nerve cells in the brain. And nerve cells already have a difficult time regenerating, and so with the radiation, it makes it far more difficult. And in the scholarly journal from Scientific Reports in 2018, research said that acute radiation exposure damages the epithelial cells in your lungs as well, and so it can cause a variety of problems. It also causes cataracts, and those are the more long-term effects. Certain solar flares on the sun could potentially cause acute radiation damage, but that's usually not as focused on by scientists because you can predict solar flares to a certain extent, and so that's not usually a worry. They usually try to veer away from planning a space mission during a solar flare. But there are 3 ways that they're trying to protect astronauts from radiation. There's the operational